Hi, I'm Sarah Miller with the West Virginia Department of Environmental Protection, and I'm here today with Kylie Joins.
We're with the DEP's Wetlands Program, and we're here to demonstrate the West Virginia Wetland Rapid Assessment Method at a field site for you.
These videos were created as a supplement to the user and reference manuals. We recommend you have a copy of the field form handy so that you can follow along as we do the assessment. You can find all the resources for WVWRAM on the DEP WVWRAM page at the link on your screen. Also, there's a link in the description to a copy of the field form with the data from our training site in Canal State Forest. Before entering the wetland, we want to do some field preparation. And the first thing we want to do is decontaminate all of our equipment. Here's a short video on how to do decontamination.
It's important to decontaminate all your equipment and tools used at wetland sites to help prevent the spread of disease and invasive plant species between wetlands. It's best to decontaminate before leaving for the field. That way you start out with clean gear. Just follow these 4 easy steps for decontamination. First, use a stiff brush to remove all soil, seeds, and vegetative matter. Don't forget your boot treads. Next, rinse with clean water. A pump sprayer sized according to the needs of your crew makes it easier when you don't have access to piped water. Then spray everything down with a 10% bleach solution. That's 1 part bleach to 9 parts water, and let it soak for 5 minutes. That includes the bottoms of your boots. You'll need to use or replace your bleach solution once a week, since unlike concentrated bleach, it loses its effectiveness over time. A small spray bottle should work fine. Finally, rinse everything off with water. You should never introduce bleach into a wetland. If you do have to decontaminate at the field site, set up a decontamination area at least 100 feet from the wetland edge. Thanks for doing your part to keep our wetlands healthy.
And as for all field work, there's a specific set of equipment you'll need. We're going to go over what that field equipment is now. Here we have an image of all of our field gear, and we'll highlight some of the things that may be new to you. First is the aquatic bed sampler. They come in several forms, but ours is a little grappling hook on a rope. With this, we can toss the hook out into a vegetated open water body and pull it back in to see what vegetation is dominant out there. Next, we have the alfalfa dipyridal strips. Press a strip into a fresh, damp face of soil and let it sit. If the paper or the soil turn pink, reduced iron is present. This is another sign that the soil is indeed wetland soil. Some other handy gadgets that we carry include things like a DBH tape to measure the diameter of large trees, a rangefinder to help with stream measurements, and pruners to help get through thickets or help take samples of woody vegetation. For a complete list of equipment, check the WVWRAM user manual in section 2.3. One final task you need to do before you get into the field is make sure you have maps available. So either you can print them out or have them available on a mapping app like Avenza, so you can have them available offline. So you want to make sure you have maps of your assessment area, that is the wetland you'll be assessing, maps of your buffers, which you can assemble in GIS and print out. And one thing that we find helpful to have in the field is a hillshade map, so you can see the topography. It's especially nice if the imagery is covered in a lot of trees and you can't tell much about the landscape.
So after our field preparation is complete, we can start to fill out the field form. And at the top of the field form, you want to give your site a distinct name and a distinct site event code. The site event code can be a stream code, which is what we use at DEP, or it can be any code that you want to use in your numbering system. Next, make sure that you've filled in the sample date line. This is good for your records and allows reviewers to determine whether or not you are sampling in the target time frame. Then record the name of your field crew leader as well as any other personnel present at the sampling event. This way, questions can be directed to the right person.
And next is the timing, so you'll need to note the start and end time for your wetland assessment. And based on the complexity of the site and the size, your crew, all of that, the timing can vary.
And you also want to mark off at the top of the data sheet that you have indeed decontaminated your equipment.
Just another backup check. And then you need to make sure you mark down your GPS coordinates for the site. So just a general representative point. You'll need to make sure you include your GPS make and model as well as the datum you use for your points. And as we proceed into the assessment, you need to remember to be looking for a few things. That includes structural patches, features like open water and mud flats, and tip-up mounds and coarse woody debris like logs, because that'll be marked later on in the form. So think of it as a scavenger hunt, things you need to keep an eye out for. And also, as you move through, you need to be making sure you take pictures of stressors and key features,
as well as the inlet and outlet.
Now that we have the top section of the form filled out, we can move on now to the non-regulatory information. So this doesn't factor into the score, it's qualitative information collected about the way the public can interact with the site. The first thing we need to write down is that this is public land. It's on Kanawha State Forest. It's always good to make a note of what the public land is when you're on public land. So in the next box, you can go ahead and mark that there is no known scientific or planning use, as well as the fact that there is no investment, such as compensatory mitigation.
You also want to note any other public use at the site. Here we have that the wetland is visible from the roadway, and also that there are other non-consumptive uses in the wetland, such as wetland classes. Also, is there any recreational infrastructure at the site? And here nearby we have maintained parking, as well as trails nearby. Once you've completed your field form, the field crew leader should mark off that they have checked the field form, and you want to denote the end time.
You also need to include directions, which isn't just the written directions to the site, but also include things like landowners you might need to contact, gates you might need to go through, any sort of logistical issues like that.
And also, to complete the top of your form, you want to put down any notes. Don't leave this section blank. Put down anything about the history of the site, anything else that you've noticed that could be relevant about the hydrology, anything that you've noted in any part of the data sheet where there wasn't a comment section, anything that was unusual.
And it's also good to just sort of try to describe the entire site so someone reading it could get an idea of the lay of the land.
Yes, paint a word picture.
Yes.
So for this section, we're going to talk about the hydrology section. And this will include the stream measurements that we take. This is something that you want to do toward the beginning of your field assessment so that you know if the stream is flooding the site or if it's entrenched or incised. And so at the bottom of page 2 on the field form, there's a worksheet section at the bottom. And you can fill in all of your measurements on this side and show your calculations on this side. And these help to determine if the stream is incised or entrenched. And if you look back in the bottom section, or river disconnection, you can see that these entrenchment and incisement are both described, like at what point does it become incised. So those are already written here for you for reference. And so we're going to show you how we're going to do that. We're going to be demonstrating the field measurements that we take at a straight stream section in the stream segment behind us. And this isn't the stream section that normally floods our wetland. This is just more easily accessible for today. The pictures that we'll include as we go along will be actually taken from our forested wetland itself. So for our first stream measurement, we want to get the maximum bankful height. And so Kylie's standing in the sow egg, and she's going to get the maximum bankful height from there. The sow egg being the deepest part of the stream.
Like 80 centimeters.
Okay, so I'll put down on this portion of the data sheet 0.8 or 80 centimeters. Again, we're just using this location for demonstration purposes. When taking the maximum bankful width, you want to look at the bank and see where the vegetation is no longer disturbed by the flood flows. This will be the point at which you want to take your height. So for our second measurement, we're going to measure the maximum bankful width. So from that same bank height, we're going to go all the way across the channel and see what that width is using our tape measure. And at this location, that is 8.8 meters. So here we'll denote that in the same section of the data sheet, 8.8 meters. And then also just above the bankful width, there's 2 times the maximum bankful height. And at this site, that's going to be 1.6 meters. For our last measurement, we're going to get the lowest bank height. And for the lowest bank height, you want to go to your shortest bank, which will be the one to my right here. And you want to go to where the top of the bank starts to crest over. And I can show you what I mean by that. So here I'm still in the channel, going up the bank, and it starts to crest over right up here at this level. And so we want the stream depth from the Thoweg, from the deepest part of the stream, to that level. And so I'm gonna estimate here. We had 0.8 in the center of the channel, and we're gonna add about a meter. So we're gonna get about 1.8 for the lowest bank height. We also need to determine the flood-prone width at 2 times the bankful height. And our bankful height was at 1.6 meters. So I'm going to extend out to 1.6. Which is about here. And I'm going to look across at both sides of the channel and see about where and how far this will extend if it were at this level. And I think it will just get out of both sides. You don't have to be terribly precise with this measurement unless you're dealing with a narrow floodplain or a narrow channel. But since this gets out on both sides, we're going to say probably about 100 meters. Now that we've done our stream measurements, we can go back and do our calculations and determine if our stream is entrenched or incised. So for this stream, after doing the measurements, we can see that our stream is not entrenched, but it is incised in this location. Later we'll see that our stream next to our wetland isn't incised, but in this case the bank is high and the measurement exceeds the bank height ratio. So we get a 2.25, and so that's greater than the bank height ratio of 1.5. And so unfortunately this section of stream is incised. So now that we have our stream measurements, we can start to fill out the hydrology section of the field form on page 2.
And with our stream measurements, we determined that the overbank flooding definitely includes at least 10% of the wetland, so it counts as a floodplain wetland.
And looking at the largest water source, we noticed that there is a barrier between the stream and the wetland, and so the largest water source actually turns out to be overland flow. So for our largest water source, we're actually going to mark that there's no visible inlet and that the wetland is partially separated from Davis Creek.
And for an outlet, there are a few little overland channels you can see where precipitation can run off and then meet Davis Creek. So our largest outlet is intermittent or ephemeral.
So in the next section for overbank flooding, we're just going to mark braided stream channels and that the flood-prone area overlaps 10% of the wetland.
In the disconnection from the stream continuum section, the first thing you'll want to mark is physical barriers between the stream and the wetland. In this case, it's a really old railroad berm from the early 1900s.
And we'll also mark that the stream channel was straightened, so it's been moved to the toe slope.
And the final thing in that box that you'll want to mark is the fact that the stream banks are steep and eroding.
Now that we've finished filling out the hydrology section, we want to remember to take any pictures of the inlet, the outlet, and any stressors, such as the railroad grade. So let's go ahead and do page 4 of the field form. This is going to be the soils page.
And unlike when you're doing soil for delineation, with WVWRAM we like to take soil from the center of the habitat type as opposed to the edges where the transitions happen.
So let's go ahead and show how the soil is excavated and sampled.
So for our soil samples we use a Dutch auger and we mark it every 10 centimeters for reference. You're welcome to use an auger or a shovel or whatever tool works best for you, that's up to you. So, to get the soil sample, we want to make sure we clear the litter from an untrampled area. And then, so the first bite here will go down to 20 centimeters. We lay that out next to the soil hole. And then try to go back in and get another 20 centimeters. So the soil hole is 40 centimeters.
And there will be times when you can't get 40 centimeters if you hit a rock or if the soil's too compacted. But you'll just want to get what you can get and use the soil amount that you get out of the hole. On the other hand, if you hit an organic soil, you want to excavate until you get to the mineral layer or until you get to 80 centimeters if it's organic all the way down.
So now that we've got our soil excavated, you'll want to make sure we lay it down beside the hole and try to lay it out beside the measuring device, which in this case, it's our auger. See, it's up to 40 centimeters. So you'll want to make sure you break open the soil profile to get a nice fresh face. And then at this point you'll want to make sure you get a good picture of the soil profile, as well as photos of the habitat surrounding.
So now that we have the whole profile laid out, we want to look down to 10 centimeters. You can measure along the auger here, and that's where we want to take our soil pH. So I will open up my kit, and we want to use about a chickpea size piece of soil to get our soil pH. Something about like that. And we'll add the liquid reagent first to make our slurry. And the amount you want to use will vary depending on the soil type. So we'll start with this. Mix that in really well. Needs a little bit more. And you want the soil to be just firm enough after you mix in the reagent that you can mush it into the side of this little cup. So you've got a fresh, flat face that's kind of sloped. The next thing that we do is we add the powder reagent. It's helpful to shake it up and pull the cap straight up and off, because this screen will screw off and you'll lose all your reagent. And the easiest way is to tap it on the bottom like a ketchup bottle, and you want to get a good dusting, good even dusting, like fresh snow, over the top of the soil there. And then we let that sit for 2 minutes, and then we'll take our soil pH color.
So after you've taken your soil pH, the next thing you want to do is make sure you've got some good notes on your soil profile. So we usually start out with going from the surface down and describing the different layers that are present, changes in texture and color. We record things like the Munsell color notation and percentage of redox and soil texture and anything out of the ordinary, such as organic material inclusion that you might want to mention. The more notes, the better. It all helps you down the line and also the reviewers looking over your permits. And finally, another thing you want to mention, if your soil does meet indicator, go ahead and write that down. Because we take samples in the middle of the wetland, your soil may not actually show an indicator, and that's fine, because usually indicators show up at the edges.
So I'm just going to do a quick review of using the Munsell Soil Book. And we usually start on the 10YR page. And you want to make sure you don't have your sunglasses on and that the sun is over your shoulder when you're reading the soil color. You'll place your soil behind the page and match it to the exact color. And so here we have a 10YR 4-1. If it's a little more yellow, we can flip this way. If it were redder, we would flip this way. There's also, toward the front of the book, we use this a lot, is the reference page that can look at your redox features, and this will help you get an estimate of the percentage of redox in your soil, and this is about 10%.
So now that we've seen the soil and taken all of our measurements, we can now start using that information to assemble the National Wetland Inventory Code to describe the soil and habitat type. So as you can see, we're under a forested canopy and it's deciduous trees. So for that, we call that palustrin forested, which is abbreviated PFO, and 1 signifies deciduous.
So the next part of the NWI code is the water regime. And here, because we're standing in what was a vernal pool in the spring that is now dried, this is a wetter water regime. And because it is flooded part of the year, this is a seasonally saturated flooded water regime, or E.
So our next column is special modifiers. This site doesn't have any special modifiers, but we'll still review the concept here. So special modifiers are letters that are used to describe any modifications made to the wetland, and this can be from people or from wildlife. So some of the examples here would be farmed or impounded or beaver dammed. When you're choosing which special modifier to use in your code, be sure to start from the beginning of the list, and whichever occurs first, you go ahead and use that modifier. For example, if your wetland was both excavated and had some beaver activity, you'd notice in the list on the form that beaver is first on the list in front of excavated, and that would be then the code that you use with the lowercase b.
The next part of the NWI code is the soil pH. So remember, we took the pH sample and we waited 2 minutes, compared it to the card, and it was about 6.7. This puts it in the circumneutral range, which will give the code the letter T. These are really wide ranges, so you don't have to worry about deliberating too much about it. If it's a little more one color or a little more the other color, if it's on the edge, then just make that call.
And the final piece of the National Wetlands Inventory Code is whether the soil is mineral or organic. Most of the soils you find will qualify only for the mineral, which is represented with N. The only soil that qualifies for a G for organic is if you have histosol, which is at least 40 centimeters of organic material in the top 80. So that is a lot, and therefore it doesn't happen so often. So altogether, the NWI code for this part of the wetland is PFO 1ETN.
Then the other NWI type at this wetland is a PFO1BTN. So everything the same, but it has a different water regime. And this is due to water not pooling in that section of the wetland, but running off or keeping it saturated. So this is the seasonally saturated water regime.
The final 3 rows on the soil page relate to whether or not your site has organic soil. This site has no organic soil, so we're marking either zeros or not present in each of the lines. In soils that do have organic soil present, be sure to consult the notes to make sure you're documenting things by the correct name.
It's important to have a good understanding of the different kinds of organic soils. There are different types of truly organic soil, and there is also mineral soil with a high organic content.
Organic soil is formed by plant matter at different stages of decomposition. Some features that organic soil usually has include a greasy or snotty feel and a lack of grit. Sometimes you can mistake plant seeds or other bits of plants for grit, but a quick look with a hand lens can usually help you figure out if it's seeds or if it's sand.
Some other characteristics of organic soil include how it dries. So in organic soil, if you smear some of it on a white piece of paper, you'll notice that it dries much darker than mineral soil. Organic soil also weighs less than mineral soil. So if you take the same amount of organic soil and mineral soil in each hand, you'll notice that the organic soil will weigh much less.
There are 3 different types of purely organic soils: peat, mucky peat, and muck. The first type is peat or fibric soil, and it is the least decomposed of the bunch. So with peat, you can often see recognizable plant fibers, which peat is often made of moss, but it can also be made of sedges or other vegetation. So in peat, that should be recognizable. Also, if you take a chunk of the peat in your hand and squeeze it, the water that comes out should be clear.
Usually the next layer down in organic soil is a mucky peat. And this is more decayed than the peat soil. You can rub it in your hand 10 times and use a hand lens to see how many fibers there are. And this will help you determine that it's a mucky peat. And also, if you take the same amount of soil and squeeze it, you'll notice that you'll get turbid water coming from this soil.
The most decomposed type of organic soil is muck or sapric organic soil. It showcases that greasy and snotty feel and has very little to no recognizable plant fibers within it. If you squeeze a handful of muck, it will extrude between your fingers like Play-Doh instead of just squeezing water out, and you should be left with not much soil left in your hand.
So another soil with a high organic content is a mucky modified mineral. This soil will have a greasy feel similar to a true organic soil, except after 3 to 5 rubs it will be gritty and feel of sand. Also, if you take an amount of soil in your hand and squeeze it, it will yield turbid water, and it won't completely extrude like sapric soil.
So for more clarity in determining whether your soil is organic or mineral, there are several tests you can do. Refer to pages 6 through 8 of your reference sheets for detailed instructions.
And there are no organic soils at this site, but we can demonstrate some of the tests. And we'll start with test 2, or the air dry test.
So earlier Sarah mentioned that organic soil dries a lot darker than mineral soil. So what you do to determine this is you take a piece of soil and rub it on the margin of your paper, and make sure you color it or take a picture of it beforehand, and then do the same again after it's dried to see if there's a great change or not.
While we're waiting for test 2 to dry, let's go on to test number 3. This is the rubbed fiber content test. For this test, you'll put an amount of soil in the palm of your hand and rub it back and forth with your thumb, careful not to drag in new soil. Then you'll look to see how many fibers are left in your palm. And this can help you determine if this is an organic soil or even if it's a mineral soil.
And finally, the last test we're going to demonstrate is number 5 on the list, and that is gritty feel. So for this one, you also take a bit of soil and place it in your palm and rub it with your thumb. If you feel grit after just one rub, that means that it's mineral soil. If you'll feel grit after 3 to 5 rubs, that means it's probably mucky modified soil. And if after 10 rubs you don't feel any grit still, that means that it's almost surely organic soil.
You'll notice that some of these tests can be misleading if they're taken individually. So you want to make sure that you're doing multiple tests on the same soil in order to build a good case of evidence for the soil type that it is. At this site, we have a mineral soil, and we know that because of the gritty feel, the way that it dries light in color, and it's much heavier than organic soil, and so we have a mineral here.
So now on to some examples of organic soil. Since we don't have any organic soil here, we've gathered some photos from site visits at other locations so we can show you what to look for.
In these first photos, you can see a peat or a fibric soil exposed in the top of a soil profile. You'll note that there are large visible fibers. The second photo is a good example of a sphagnum peat. You can see the dead peat fibers, still obviously sphagnum.
So in this photo, you can see that sometimes peat doesn't always occur right on the surface. This peat is buried under agricultural overburden, which happens from runoff over years. So remember, your organic soil may not be the very top layer.
A deep organic soil can include all the types of organic soil. In this image, you'll see a peat at the surface with a layering of sapric and humic soils throughout the rest of the profile, ending in a mineral soil at the bottom. Because this organic soil is greater than 40 centimeters thick and within the upper 80 centimeters, the soil is classified as a histosol.
Histosols are 40 centimeters of organic material in the top 80, but there's also histic epipedon, which is superficially, so just at the very top, 20 centimeters of organic soil present. And remember, if histosol is present, that qualifies the soil for a G in the NWI code. But histic epipedon does not qualify for that G. It's just an N. Now we're on to the vegetation page. Remember, our index period is May to October in areas with elevation below 3,000 feet, and June to September in areas above 3,000 feet. This is in order for the data to be comparable with other data that's been captured for WVWRAM. It's important to remember to take pictures of each NWI type as you go, so depending on the layout of the site, you don't miss one and then have to trek several acres back to get to it.
Some helpful resources to have in the field are apps on your smartphone as well as field guides. For our sites, we use 2 apps on our smartphones. One is the Virginia Flora and FloraQuest. FloraQuest provides a good key for West Virginia, while Virginia Flora provides better descriptions. The only physical field guide that we use right now is the Grasses Guide by Sarah Chamberlain. So vegetation cover types are mapped where they cover at least 1/10 of an acre and are at least 30% cover.
And the cover type is determined from the top down. If a habitat has 30% trees, then it's a PFO, a palustrine forested wetland. If there isn't 30% trees present, look down at shrubs and so on.
So at this wetland, we have 2 habitat types. We have a PFO-1B and a PFO-1E, so that's 2 forested types with different water regimes. These are listed in the first column of the top of the datasheet, and these will correspond with the 2 columns of vegetation. So column 1 will correspond with the PFO-1B on blank 1.
And as you walk through the wetland, you'll observe dominant plant types. Those are plants which have at least 10% cover throughout the wetland. So whenever you see these plants, you go ahead and circle the line in the columns corresponding to 1 or 2, which habitat type you're in. And then later you'll determine numbers for percent cover.
When you're determining percent cover, you can each call out a number and just take the average of the 2. Botanists will often argue about the percent cover, and everyone notices different things, so it's just easier to take an average.
While it's necessary to record all dominant plant species, the ones over 10% cover, we also tend to enjoy recording whatever other plants that we find interesting that we find on site, even if they're less than 10%. Say if you find a neat orchid or something like that, it's nice to have for reference. Also, you'll notice that in the vegetation list there are several plants that are bolded, italicized, and underlined, and those are concerning invasive species. And they need to have their percent cover recorded whether or not they have a 10% or greater. It could be just 1% of multiflora rose, and you would still want to make sure you write it down on the form.
Once you finish with veg cover, go ahead and calculate the totals for each NWI type.
They'll usually come out to over 100%, but in a few cases, such as PABs and PUBs, you will end up with less than 100% vegetative cover identified. So in those cases, you need to make sure you also write down the total vegetative cover for the entire NWI type, including the plants that you didn't identify on the form.
For reminders on completing the veg form, look to the top of page 5 in the 2 gray boxes.
And for the percent AA column, or percent of assessed area that each NWI type covers, it's best to do that calculation after you've made your map in GIS.
If there are plants that you find in the field that are difficult to ID, take extra time, or you need to consult with a botanist, be sure to bag those plants and put them on ice to transport back to the office, put them in a press, or transfer them to a botanist to identify later. So now that we've completed the vegetation section of the field form and we've backfilled our soil holes, we can now go back to the front of the data sheet and we can look and make sure that we've taken all the photos that we need for the site.
Write your photo descriptions and some reference numbers on the photo log page, which is towards the back of the form and after the large vegetation list pages. Make sure you've taken a picture of all the key features. So the inlet from the runoff from the road, the outlet to Davis Creek, the PFO1 BTN habitat, the PFO1 ETN habitat, the soil for the B and for the E, as well as stressors and anything else of interest. The more photos, the better. It helps you reference things later, and it helps the reviewers.
For this site, we also have photos of features like the perched culvert from the road, the paved road itself, the power line stressor in the buffer, Davis Creek Trail, which breaks the buffer on the east side, an example of coarse woody debris, crayfish burrows, and a large tip-up mound.
So now that you've checked off that you've taken all your photos, we are back on page 1, and we're looking at the assessment area box. So in this box, we'll indicate whether we've assessed the entire wetland unit, a portion of a much larger wetland unit, which in this case we're using greater than 25 acres, or just the project area, which often happens with restoration sites. So for this site, we assessed the entire wetland unit.
The next section is the purpose of the assessment, and for restoration sites, you'll usually mark that it was restoration and how many years out, that it was baseline, or that it was pre-impact. You can also mark multiple boxes for this section, say that it is a restoration site and it's a revisit.
Next is the buffer section. So for this, you'll want to consult your buffer map that you've pre-made in your office, and we tend to use PDF geo-referenced versions of our maps that we can bring up in Avenza, but you can also print it out if you want to. So essentially what you're going to do with this first is find the areas where the buffers are broken and mark them out on the map. So we do this with a screenshot on our phones. Things that break the buffer include roads, heavily used trails, railroads, pastures, any of the sort. So essentially the qualification is, would a salamander be able to walk across it and be unscathed? So for our site, we have marked off at the Davis Creek Trail on the other side of the creek because it is heavily used, and we've marked off the road here through the park. Now you go to the different boxes for the buffers, and referring to your map, you approximate the percentage of remaining intact buffer and mark it for each box. After rating the perimeter and natural buffer, based on the buffer map and site observations, mark the box for current land use in the mapping section. Use the rest of the mapping section as reminders to collect this information while in the field, checking each item off as it's completed.
For special conservation concern, you want to refer to the user manual to look at the definition for each potential type that could be at the site. Here we don't have a special B rank, and so we mark none next to B rank, and we mark no known special concern in the bottom of the box. You can see that we had a forested wetland, and so one of the things that you might want to consider is a mature forested swamp. And here, our wetland didn't meet that definition.
So next is the depressions box. In this box, we'll want to indicate just how many depressions are present in the surface of the wetland that could hold water for up to a week after a flood. Several things to consider in this are the amount of freeboard. So essentially, if the pool is already full, it doesn't count. And if the water drains too quickly off the land, it also doesn't count. So if your pool already has some water in it, just consider the amount of freeboard that exists in the pond. So here we have a bunch of empty vernal pools with absolutely no water in them, and they're scattered across the wetland. So we're giving this 10 to 33% cover of depressions.
For microtopographic complexity, this is the roughness of the ground surface. And there are some criteria that you can follow in determining which of these you want to rank. So there are 3 different rankings. The first is less than 3%, and if you can walk across the ground surface easily, as if you're walking through a wet hayfield, then you'll rate it less than 3%. If you're kind of watching your feet and you're stepping over logs and tip-up mounds and that sort of thing, then it'll be more like 3 to 40%. If you're high-stepping it through a peatland, you're watching every footstep, you're maybe losing a boot, then this will be greater than 40%.
Next, we have karst topography. Here at this site, we don't have any, so we mark no features present. Karst topography is dominated by limestone geology, which can create interesting features like caves and sinkholes and springs. So it's highly regional, so for the most part, it's only found along the border of West Virginia with Maryland and Virginia, and over in the Eastern Panhandle. There are online maps that you can refer to if you're not sure if your site may be in karst territory or not.
Structural patches are features in the wetland that create habitat for plants and animals. When you're looking for these features, you want to think about the size that they fill. So think about a 4x8 sheet of plywood. One of our structural patches is crayfish burrows. So do you have enough crayfish burrows to fill that 4x8 sheet of plywood? You can also visualize melting that 4x8 sheet of plywood over a tip-up mound or wrapping it around snags. You just want to make sure that however you can visualize it, that you're getting enough of that structural patch.
So first on the list, we're marking open water and pools inaccessible to fish. Now we're able to mark these because of prior knowledge of the site. We've visited here in practically all seasons at this point. These habitat structures are provided by the vernal pools when they have water in them in the winter and the spring. So the open water, in order to qualify for this, needs to be unvegetated to the point that a bat could swoop down and get a drink of water out of it. And it's always important to remember the purpose of the pools inaccessible to fish is amphibian breeding habitat without the same amount of predator pressure you would get in a creek.
At this site, we're also marking non-vegetated mudflats and animal mounds and burrows. Non-vegetated mudflats are areas of open mud that something like a woodcock could probe for food. And here, because we have vernal pools that have dried, they've left behind mudflats. And so we end up being able to mark both open water and mudflats. And also for animal mounds and burrows, again, this is all crayfish mounds, and we had enough to fill that 4x8 sheet of plywood.
So next on the list, we're checking off abundant deciduous leaf litter. Since this site is seepage fed and not generally flooded, it allows the fallen leaves to build up over time and create a good bug habitat that birds can forage in for food. And we're also marking off the first of the 2 coarse woody debris checkboxes. So coarse woody debris is just any large sticks or fallen trees that are lying on the ground. So we're only marking the first because the second checkbox would mean that we have at least 3% cover of the entire wetland covered in coarse woody debris. The really easy way to tell is, are you struggling to get around all the logs when you're going through the site. It's kind of like the microtopographic complexity. So essentially, there were a few logs here, but not a ton, so we're just marking the first of the 2 boxes.
On the other hand, we get to mark both of the options for snags. We have enough snags at the site that equal at least 3 per acre. So we have a high density here. It's important to note when you're thinking about the differences between coarse woody debris and snags, that sometimes you could have a snag that's leaning or a dead tree that's leaning, and you have to determine whether or not to call it a snag or coarse woody debris. And if it's greater than 45 degrees, if it's more of an obtuse angle, you can call it a snag. And if it's less than 45 degrees, you can call it coarse woody debris. Also at the site, we had a large tip-up mound, so we'll mark that as well.
And that was our list of the structural patches that we did have at this site. You'll tend to notice that more complex sites and forested sites tend to have a lot more structural patches present. So as for the structural patches we didn't have, lots of them, like oxbows, springs, and beaver infrastructure, are pretty self-explanatory. But I'm just going to give you a little note about hummocks and tussocks, just because you don't always get to see them. So tussocks are where grasses, sedges, or other graminoids grow together in a clump, and their roots intertwine and make a mound on the surface of the ground. You can typically feel these when you're walking past them. It's the tough root wad at the bottom. And the other one, hummocks, tend to be formed by the buildup of dead vegetative matter over time, and that creates then also a mound in the microtopography. And these tend to happen in peatlands or shrublands, and they usually allow plants that are less water tolerant to grow atop them and provide even more biodiversity in the habitat.
So now that we've finished with page 1, we'll go on to page 2, and we'll fill out vegetation structure. Here we have 2 boxes that are specific to forested wetlands, 2 boxes that are specific to emergent wetlands, and 2 that can be used to rank all wetland types.
So this first box in the list is one of the forested type only boxes. So it is related to the structure and strata of the forested wetland. So here you see listed all the different layers, from canopy to understory to shrub to herb to moss. And these have to cover at least 5% of the wetland, or 1/10 of an acre each. At this site we were able to count everything but moss, since we had copious amounts of all the other types of vegetation.
The second PFO only box to rank is forest regeneration. And here you want to look at the tree species that you have in the canopy that make up at least 10% cover, and see if those species are in the sapling layer. And what this means is trees that are 6 feet or higher, those trees that are outside of the deer browse range. So you won't be looking at seedlings and things that a deer could readily eat. At this site, although we have sycamore, we've noted that sycamore tend to grow at edges and in gaps. And so even if we don't have sycamore in the understory, we don't count it against the forest regen section. And so at this site, we were able to mark yes for forest regeneration.
And the third box is one that applies to all wetland types. So this one's vegetation fringing open water. And this one's pretty particular. It's got to be at least 10 meters wide swath of wetland vegetation surrounding open water, which in this case is a lake, a pond, or a stream. So here we don't even have open water right now, so we're able to mark no on this box.
It's important to remember the difference between the 2 open water definitions. So we have our open water structural patch, which we want to remember that that's just a 4x8 sheet of plywood ranked under the structural patches. Whereas vegetation fringing open water is a larger open water source, like Kylie said, such as a lake or perennial stream.
So the fourth box is one of the emergent only wetland rankings. So this one is sort of like the forest canopy structure, in that it's looking at the different height strata that occur in an emergent wetland. So there are 3 categories, less than 30 centimeters, 30 to 100 centimeters, and 100 centimeters or more. So when you're visualizing these, think of, say, the height of water willow, the height of soft rush, and the height of cattails. In order to count, the patch needs to be homogeneous in height, but not necessarily in species. For the less than 30 centimeters, imagine patches of Eleochorus interspersed with water willow, and that's all the same height, so it counts. If your wetland has a bunch of mixed heights, just go ahead and pick the tallest one and select that category.
So the fifth box and the second PEM only box is for tall graminoid marsh. So we have a forested wetland here at Kanawha State Forest, and so we don't have any tall graminoid marsh, and we'll mark it as none. But tall graminoid marsh is usually something that is composed of cattail or bulrushes, and it will make up about 1/10 of an acre. And so in those cases, you'll mark a tall graminoid marsh. There also, the last box number 6, is mowing. And so again, at this site, there's no mowing within the wetland, and so we'll mark none for this site.
So now, if you turn to page 3, we'll look at the stressors and fill in these boxes. You'll notice on this page there are the little round check boxes that we refer to as radio buttons, as well as the square check boxes. The radio buttons are more for the purpose of getting your thoughts together and checking off the different features you see in the wetland, but they don't contribute to the score. That's only the square check boxes.
So hydrology stressors affect how water moves in and out of the wetland. And you want to think about how many of the radio buttons you select when rating this section. If you have a lot of radio buttons selected, then you want to think about, how heavily this might impact the score. So it could be moderate to severe if you have a lot of radio buttons selected. But since at this site, I think we marked 5 radio buttons, and because there are 5, but they have not a huge impact, each one doesn't have a huge impact, we marked minimal for this site.
For water quality stressors, mark the discharges and pollutant sources that you see coming into your wetland. We just marked discharges here, and to specify for clarity later, we've circled or underlined the different actual stressors that we're finding. So in this case, we marked stormwater runoff, which would be from the road salt, which would be from the road in the winter, and right-of-way herbicide, which could drift over after spraying from the right-of-way just outside the wetland.
For vegetation removal and alteration, we want to consider the vegetation type in the wetland. So here we have a forested wetland, and usually when the wetland is forested, the rating is probably going to be not that harsh. And here we've marked it as minimal. In other cases, if you have an emergent wetland, this could often be severe, especially if it's grazed. It may also be moderate impact if it doesn't have a shrub layer. A shrubland could also be moderate, or it could be minimal, depending on the climax growth form for that community.
And the final box on this page is soil stressors. So this represents any sort of actions that have happened to the soil that impact how it forms or how it exists now, which that can be anything from cattle trampling to large machinery or ruts from vehicles. So here we don't have any of the sort, so we marked intact. Now that you've mostly completed filling out the data sheet, it's time to make sure your housekeeping is done. At the top of all pages after page 1, fill in the site name, date headers, and page numbers for any additional pages. Additional pages may include vegetation forms, soils pages, and plant vouchers. This helps you keep pages together if forms are separated. When you're done filling out all the headers, go back to the front page and write the final page total in the top right corner. And finally, it's important to make sure your coworker reviews the data sheet before you leave the site. It's possible to overlook sections of the form, and checking it in the field ensures that you can accurately rank anything that's been missed while you can still see it in person.
Now we have finished filling out our data sheet in the field, it's time to process and score it back at the office. So on the front page of our database, I want to go over the different functions. This is, at the top, enter your new record, and we'll go over that once we begin to enter our data from Kanawha State Forest. Import GIS results is what we'll do at the end after the data is entered. And you can also view preliminary GIS score report. And this section is the preliminary GIS score report. So before the scores are calculated, you have brought in your Excel file after you've imported them here, and you can view that here under this section. And then once the GIS results are imported, again, you'll calculate that here. And we'll go over this a little bit later. And then here's where you would view that final score after it's been calculated. And this is a datasheet view, so you can view your datasheet if you want to print it. And you can also go in and review your record. So if you accidentally close out of your datasheet while you're entering data, this is where you would go to reopen it. And you can either search by the site event code, or you can search by the site event name. And you can start by typing it in, or you can just take the drop down and pick from the pick list, review record, and you've pulled it up, and you can go back in and edit your record that you are working on. Okay, and you can also go in and view the record. So here, if you want to view it without accidentally changing something, you can view it here. So view only mode active. And at the bottom of our front page, we have several different tools that are handy when you've got a database full of data and you need to edit things. So you can duplicate a record. So if you're going back to the same site and you're only making minor changes, you can pick a record and duplicate it, and all of that data will be in the database under that duplicate name. And then you can just go in and edit the things that you actually needed to change. You can also rename a record. So if you have a couple records that have the same name and they're starting to get confusing, or you maybe a site has changed hands and you need to rename it for a new landowner or something like that, you can go in here and rename a record. And if you don't need a record, or you created a record that you didn't need, or you're running scenarios, you can delete records using this. And if the GIS results came back and you needed to change something, maybe you had to add a new NWI type or something like that, then you can remove the GIS results from the ones that you submitted and used to calculate the final score, and then you can re-import. You don't want to have GIS results on top of GIS results.
So when you get back to the office, it's best to do your mapping as soon as you can, and you'll use the GPS points that you collected in the field, use the existing polygons, and draw the new sections that you picked up in the field. One of the most important things you need to check on is to make sure that the polygon you've created is compatible with the GIS tool. You need to make sure everything has the right attributes associated with it. So with that, you need the survey date, the attribute, and the site name. So you'll want to make sure that your attributes for your polygon match the attributes that the GIS tool needs to read. So that includes adding acres, which is a double field, survey date, which is a date field, and attribute and site name, which are text fields. So then it'll be able to communicate with the GIS tool correctly. So you can see here we have the PFO1B and the PFO1E interlocking, and so we've got that, and we can go ahead and submit to the GIS tool. So I'll close out of GIS here. I didn't change much, but there we go. Okay, so we'll need to go into our web browser. The URLs here go into the WVRAM GIS tool. So you'll select Launch WVRAM tool, and that'll bring up this map. And so it says to prepare the polygons for input. And so if you've created your map, yes, you've validated them. So you put in your email here. Then you make the project name, which I'll just call it KSF Store Hollow 2, and then input wetland, which there's a couple ways to do that. Here I have the shapefile that we just made, and it's really important to make sure that it's zipped, or it won't be able to show up in the file explorer. So make sure you zipped your shapefile that you've exported. So you'll choose Add File and find your zipped file. Go ahead and open that. And there it is, right where you expected it to be. It's always good to make sure that it pops up where it's supposed to. And so I'm going to go ahead and submit the project now. And it's good to just click that once. It'll show, yes, this little update, and you click OK. It takes you back out to the main launch menu again. But there is another way that you can go ahead and, if you've got a smaller area or a less complex polygon, you can draw in, and I'll kind of demonstrate what that looks like. All right, so draw a polygon. You can also import a KML file, but so I'm just making a little example file here. If you need to draw something, it's just a click to draw polygon, and then you click to start drawing, and it asks you to click at every vertex. And then when you're done drawing your polygon, you double click, and then you can submit the project. So that's just if you've got simpler, and it'll only let you submit one at a time with this setup. So it's more for scenario planning, stuff like that. All right, and so that usually takes about an hour, hour and a half, depends on the amount of files that have been submitted at a time. But you will get an email in your inbox to confirm that it's been submitted, and also when the file has been successfully processed. And that'll include an Excel file attachment, which looks like this. So it'll have all of your attributes and your credits and your score. And this eventually gets uploaded then into the database after your regular data sheet input has been done. And also, another thing, if something is wrong with the polygons, if there's adjacent polygons with the same attribute, or slivers, or invalid codes, it will also send you an email that the GIS tool assessment has failed. And so all you have to do then is go in and fix your polygon, find what's wrong with your attributes, and go ahead and resubmit it.
So now that we have our GIS results submitted, we're going to take the data that we've collected in the field and enter it into the database. So first we're going to log in. User is the login name, and the password is user1. All of this information, as well as the database, are available on the WVWRAM website. And so I've got a PDF version of our datasheet here on the computer. Usually I'll be copying this over from a paper field form, but today I've got this pulled up so we can easily copy things over. So the first thing I'm going to do is bring in our site name from our field form, and we're going to create a new record. So I'm going to Control V to paste and take out the symbols that we can't use in the database. We're just going to have KSF store hollow2 PFO. And I'm going to pull our site event code. This code can be anything unique that you choose to use. Control copy that out. We use a stream code with a unique wetland identifier and a replicate number. So for us, this is actually, see here, it's asking if this is a replicate or a duplicate. And in this database, it is not. So we're going to, well, first I'll illustrate here, I'll show you here that if this were a replicate in your database, you could say yes, and you would put in the site event name of the site that you had visited previously, the same site. But since this is not a replicate, we're going to go ahead and create new record. And this isn't a replicate, so we'll choose no. And you'll notice that there are a lot of pop-ups in the database. And be sure, these aren't just things that you want to ignore. These are informative, and they'll help you as you enter data into the database. So here it says that do not jump from 1 to 3. What you want to do is go in tab order as you enter data into the database. And so, okay, so our survey date is 5/11 of 23. And our crew leader was Elizabeth Byers, and I was her field crew. We started at 11 and finished at 1. Our gear was decontaminated and the data sheets were checked, and I am the person entering the data. And then what we usually do is I'll enter all of our data, and someone else, you'll want to come in and have it proofed. And we want to grab our directions. Here, and our notes. So here we actually have, we actually have notes on here and in the overflow page of our field form. And all of these can go into the same spot. And if you end up with notes in other parts of the field form and there isn't a space in the database for it, so if there's no comment section or something under a particular section, you can always add those to this no section at the top. Sometimes we'll have some extra soils notes that might end up there. And our GPS type. Also, you can see that the field form and the database correspond. So page 1 is tab 1 and so on. I'll just copy these over, make it easy. And our Latin long. And then we'll mark that all of our photos were taken. And you can see that corresponds to this part of the data sheet. Okay. Our assessment area was the entire wetland. This was other. It was a training event. And we covered all of our mapping activities. There was no B rank and no special concern at the site. Let's see what our buffers were. So we had 75, 50 to 75, and then on the contiguous buffer, we had less than 60. In our non-reg section, so this was a public site, and we often like to note that these were what public area this was taken from. So this was Kanawha State Forest. There was no scientific planning or investment, but we did have visible and non-consumptive use, which in this case was our wetlands classes. And for our infrastructure, we had some maintained parking and a maintained road within 30 meters. And our topography, so this is the bottom of the sheet and the bottom of the first tab. So 10 to 33 on depressions, and microtripography was 3 to 40. We didn't have any karst. We had several structural patch types here, so we had open water and pools inaccessible to fish, mud flats and animal mounds of burrows, and those were crayfish mounds. We had abundant deciduous leaf litter, coarse woody debris only, the top option, and then we had heavy snags and an upturned true root wad. So now we can go on to the second tab, and again, you want to do these in tab order. There's also a spell check. I will ignore this one. So on our veg structure, so we'll go to the second page. For our PFO structure, we had everything but moss. And we didn't have a PEM, we didn't have an emergent wetland, and so we won't mark anything there. We did have forced regeneration, but not fringing open water. And we didn't have a graminoid marsh. This was all forested, and there was no mowing in the wetland. And this was in a floodplain, but the largest water source was no visible inlet, and the largest outlet was, let's see, I think that was intermittent. Yes. Intermittent, and we'll take our notes from over here since it was partially separated from Davis Creek. And again, all the notes, all the comments are important for when you get back to the office and you're kind of wondering about some of the readings that you have. I especially encounter some of these things when I'm entering the data. And so it's good to have notes, even though they're not required. And when you're submitting a WVWRAM, when you're submitting an assessment like this for someone else to review, it's important to have all those notes in case there are any questions. And so under overbank flooding, we're just going to mark the bottom two. We're in the flood prone area, and we had braided channels. Then we also had a physical barrier. Stream channel was straightened, and the stream channel banks were eroding. So physical barriers, straightened channel, steep and eroding. We go to the bottom of our second page to our stream calculations, and we have 40 and 7.5, and if you tab over, it'll automatically calculate your entrenchment ratio and do the same for your bank height ratio. So that was 0.9 and 0.8. There you go. Okay. On to our third page, spell check checks out, and on to our stressors. So for our radio buttons at the top, berm, road impervious, undersized culvert. And we also had some stormwater and a straightened wetland edge. There we go. Now, if we did have a disconnection from the river continuum on the previous page, so if we had some incision or if we had some entrenchment, then we would be able to go onto this form and mark it here so that it's accounted for. Otherwise, it will throw an error in the database. So if you have an entrenchment or incisement, make sure that you're marking something here. And this is also on the new data form. And so with those in mind, we ended up calling this mild. So the hydrology stress was mild for this site, which makes sense. It's in Kanawha State Forest. It's forested wetland. Our water quality stressors We did have some discharges to the wetland. So we'll mark stressors observed, discharges to wetland. And in other, what I like to mark is anything that I saw in the field. We tend to underline these. So we had stormwater discharges, potential road salt, and right-of-way herbicide. So I'll mark these in the notes here and other. Okay. For vegetation alteration and removal, so this was a forested wetland, and thus this would be minimal. And we have, yes, we had an intact soil. Okay. Now we'll go on to the soils themselves. Corresponds with the next page in the data sheet. And here we did a couple soil holes in the first water regime type, and then one soil hole in the third. We'll enter all of these, even though there were only 2 different water regimes at this site. So let's do the first one, the PFO 1BTN. It was sampled, and the pH for number 1 was 6.8. And we'll get our soil notes here. Also important for interpretation back in the office. I refer to these frequently. And we also had an NRCS soil scientist with us that day. Okay. And it'll do a spell check. So there we go. We have seasonally was misspelled, so I'll go ahead and change that. And now we didn't have any organic soil. So we'll mark not present, 0 depth. We measured in centimeters, and neither histostol nor histic epipeton. Then for our next soil, we'll use the arrow with the star to bring up a new form. And you want to make sure the soil sample site that you go up and number it, because this database doesn't automatically bring up the next number. And so the second soil was the same NWI type, PFO 1BTN. Sorry, capital B. Sampled, and number 2, pH was 7.1. And I'll pull in my notes from number 2. Okay. Spell check is good. Again, no organic here in the floodplain. And we'll add one more soil form, mark it for number 3. Oops. And double check that we didn't have organic. Nope. Okay, so this was our PFO 1ETN, different water regime this time. And its pH was 6.7, so these are all circumneutral. And pull my notes. Okay. And we'll mark that all of our didn't have any organics. Now, we're finished entering all of our soils data from our data sheet, but I'm going to go ahead and demonstrate how to delete a form if you need to. So I'll just put in some mock data here. And so I've entered this, and I realized that I don't need this one. So you can see on the left side there's a massive arrow for delete, and you can just come over here, click and highlight that, and hit the delete button on your keyboard, and it'll bring up, you were about to delete one record, And yes, we want to delete this record. So that form is now empty, and we can go back through. And yeah, now we're just down to our three soil forms. Next, we will go into the NWI vegetation, and this tab corresponds with the top of this page, which is page 5. And so we've got our 2 NWI types here. So here you only need to enter the 2 NWI types. We had a PFO 1BTN, and I've labeled it number 1. We identified the dominant species. It was 48% of the assessment area, and the sum of the cover was 161. So remember, if you're in a forested wetland, you are going to have more than 100% cover, or anywhere where you have layering of vegetation. And here I'm entering the second NWI type at 52% of the assessment area, and its cover was 118. Okay, that looks good. So we'll go over into the vegetation. And this section corresponds with the rest of page 5 and 6, since we only had the 2 NWI types. And what I like to do is start with, so we have our PFO 1BTN, which was our number 1. So I'm going to go down through all the number 1 columns. And you can do this any way that works best for you, but this is the way that helps me keep track of where I am. So we're going to start with our first NWI type, and if you tab over after typing the 1 in, it'll autofill that PFO and BTN, so you don't have to type that every time. And then our first species is Acer rubrum, or red maple, and as you start typing, it autofills, so you don't have to go down through the pick list. And our percent cover for Acer rubrum was 2, and then you can just tab through, come back to the beginning, type the 1, tab over, and go to your next species. So we had Betula nigra, a river birch. This was 17. Yeah. Carpinus. After Phagus, we have liquid ambar at 10%. And so you can see here how the vegetation data entry goes. And then here's your next type. You type in the 2 and tab over, and you get to your next NWI type, so our PFO and E. But I'm not going to enter all of that today, just for sake of time. And so I will just enter in this much, and I'll show you what happens when the totals here don't amount to at least 100%. So let's click over here, we'll get our error. So here we have our first warning. There are other checks and warnings in here that can help you go back and be like, oh, I forgot to enter something. And so with this warning, it's telling us that the dominant species identified is checked, so we check that on tab 5. but the percent of identified covered, so it's totaled our covers here and they're less than 80%. And so we need to go back and either edit tab 5 to meet this warning, or add the rest of our cover from the field. So maybe we left off some plants, or we left off some cover percentages. So you can see that explained here as well. So just for the sake of time today, I'm going to just give higher percent covers for these for now. And then we track our photos in the database as well. So we had an Olympus Tough camera, and Elizabeth was taking the photos. So then this field, office photo ID field, we don't actually use this one. When you're numbering your photos, you want to go to disk photo number. So you'll go down through and enter your photos that way. And your photos, your primary photos that you'll take in, outlet, inlet, stressors, NWI, and your NWI soils, and on and on. So that is where your photos go. And now that we've entered our photos into the photo log, it's at this point that you can jump back and forth between the different tabs. You finished everything, now you can jump around. You don't have to worry about going in tab order anymore. You can also, once you get to the photo log, you can now close out of the data entry for this. If you go to tab 1, it won't let you close. So go to the photo log, and it'll let you close out of that data entry form. And that is our data entry prepped and ready to be combined with our GIS import. One additional thing to keep in mind when you're entering vegetation is that the names that are used in our database are taken from the USDA plants website, which also has synonyms for the different plant species. And in your apps that you use in the field, so Virginia Flora app or FloraQuest, you can also look on the description section of those plants, and it'll often list synonyms. So if you're trying to enter a plant and it's not in this pick list somewhere, try to look up the synonyms and try one of those synonyms for that plant species. If none of the synonyms work, then please contact us and let us know, and we can add that plant species into our database and put out a new version of the public database for use on our website. One last thing on the veg sheet, if we enter in a vegetation item on the list, and let's just say it's something that we don't need. So I didn't actually have this plant at the site, so I need to delete it. Again, just like the soil section, you'll go over to the left, click and highlight that row in the box on the left, and hit delete on your keyboard, and yes, we want to delete.
Alrighty, so now that you've input your data into the database, you'll need to import those GIS results. So you should have hopefully received your GIS results email, so you need to download that Excel file and put it somewhere you can get to it. So then you'll need to go to the second row down, import GIS results. So you click on the big green button, and this big green button, and so mine's on the desktop. It's right here, this Excel file, hit OK, and then it'll make sure that's what you want, and so yes. So then it asks you to populate the codes, so it'll open up some windows, and So it'll be this, 332. And so that's the site event ID. And so you go ahead and here and say 332. Click out of it, make sure it took. So then close out of these. And then go ahead and hit finalize import. And again, it also makes sure, like, this is how many you meant to import, because you could do them in batches. And so if that looks right, click yes, and it'll tell you it's successful. So it brings up a table of everything that's been in. And go back to data main. So you can view that preliminary score if you want to, right here. And so it's a little easier to read than that big Excel file. So it clearly imported correctly, so that's good. So now you can view or calculate score. So with the above tasks done, you can go ahead and hit calculate score, and it'll run everything behind the scenes and give you a nice check mark when it's done. So now that that's been calculated, you can view the combined scores. So you just find your site in the drop-down menu. So here we're looking for KSF, Store Hollow 2, view final score. And it looks like it did pretty well. So you combined the metrics from the newly entered data with the GIS data from the GIS tool, and you get the regulatory impact score of 0.729. So now you know how to score, do data entry, and upload the GIS scores to get the combined score for your wetland polygon that you've assessed. Remember, these videos are just supplemental, and it's critical to read your user manual.
If you have any questions, please feel free to contact us, and thank you for watching.